We are team number 9 and this is our project proposal. It's me, Damon, Tyler, and Anderson. Our problem statement is we are trying to create a power plant that uses natural resources but can also be efficient and stable. Our design requirements are we have to use materials that has a price and must be exactly $50 or less, and it must have a height requirement of 2 feet or less. It must be stable and little to no fluctuation power. It must be freestanding. It must use either solar power, which is LED, water, which is a constant, and then wind, which is random. And then it must be transportable. It must be used in different places, not just one. And it must be profitable. And it must be user and eco-friendly.
Alright, for our design A, we have our motor located directly in the middle of our board for balance purposes. It has a metal bracket that goes around the motor to hold it down and prevents everything from getting loose. It's followed by a wooden dowel located directly on the spinning part of the motor, and it goes right towards the plywood wheel, which has 2 sides, and acetate blades directly in the middle, which allows the water to hit it and spin the wheel, which powers the motor in return. The motor will also have wires going back to the breadboard. For our wind turbine, we have a wooden stand, a wooden base, and wooden blades. It has several blades so it can catch more wind, and the motor is located directly on the back of it, and it's also going to have wires going from the back to the breadboard. We chose to not have a solar panel on this one because it would keep the price really low, which would be really good for our consumer.
For design B, we decided to use a windmill that has a base of a Dixie cup with nails at the bottom, and then we decided to use a paint stick. And then in the back of the fan, this is the motor, which would be hooked up to the breadboard. And then the solar cells would just be plain and sitting there with the wires, and would also be hooked up to the breadboard. And then right here, we would use a PVC pipe right here where water would flow to the wheel, which would be made out of just plain old plywood. And then we would use paint sticks to hold up the PVC pipes, and then the water would flow down, then going down into the bucket, also using the same thing, but in the back of the wheel we would hook it up to a motor and then up to the breadboard.
So first part of this design is the windmill. We have a motor connecting to gears, which is a 30-to-1 ratio, which would give out the most output, which is crucial for this design. Then we use acetate film to make the windmill part. We use PCV pipe to make it foldable. So right here there's 2 90 degrees and a solid one through it, so it is able to fold down and lay flat, which is also crucial. Then we have the solar panels. We have 2 solar cells connecting with wires, which we will connect to the breadboard. Then we have aluminum foil around with making it cave in to reflect the light and bounce it on the solar cell. Then we have here the water wheel. The water wheel we will make out of 2 pieces of balsa wood, and then we will cut slates and put balsa wood in between so the water catches. Then we have a piece of wood which the motor will sit on top, and then a dowel that will connect to the wheel to the motor. And then we have a hinge, so this is able to fold up and lay up high, below 5 inches. That's it.
Hi, so by now you have known that we have chosen design C as our design for this project, and here's the reason why. Well, if we look at cost for the different powers to come up with the different designs for water, wind, and solar, we find that the cost of design C was much expensive as compared to the cost of design A and B. So we gave design C a lower rating compared to the others simply because it was much more expensive. However, when you look at functionality, size, efficiency, and foldability, we find that design C met all these requirements while design A and B did not fulfill these requirements. So that gave Design C higher rating. So averagely, we found that Design C was better and better to work with than other designs. So